Okay, this is the final of our trig ratios here, and this final one is the cosine ratio. So we'll be skipping some stuff as we go through the workbook here. So just kind of note the problem number and find that accurate spot in your workbook. So here was our one warm-up problem today. So we want to find the value of the sine of p. So here is p up here. So sine is opposite over hypotenuse. So for us here, the side that is opposite p, the sine of p, the side that is opposite that is Sn, and the hypotenuse, that's our longest side across from the right angle, that is Pn. So Sn we don't have, so in order to find it, we will go ahead and use the Pythagorean theorem for that. So we have a squared plus b squared equals c squared. A and B are the legs of the right triangle. Try to solve for one of those. So 24 squared plus b squared equals 25 squared. See, 24 squared is 576 plus b squared, and 25 squared is 620. 625. Undo that real quick. 625. Okay, so we'll subtract 576 and we get that b squared equals 49, which means that b is 7 after I take the square root of both sides. So there's Sn. Sn is 7. So now I can come back up here, write my proportion. Sn is 7. Pn is 25. So the sine of p is going to be 7 over 25. And we could put that in our calculator and get a decimal equivalent of that also. Okay. So learning goals for today. Define the relationship between the lengths of the adjacent side and the hypotenuse in a right triangle as the cosine. Relate the cosine ratio to the secant. Use the cosine and secant ratio in a right triangle to solve for unknown side lengths. So very similar to what we've already done with the tangent and the sine. And then same with the others, we will not be using the inverse cosine here for finding angle measures. All right, so then again, our new key terms, we have cosine and we have secant. And again, we won't be using the inverse cosine here. All right, the cosine of an acute angle in a right triangle is the ratio of the length of the side that is adjacent to the angle to the length of the hypotenuse. All right, so we saw that tangent was the opposite over the adjacent. Sine is opposite over hypotenuse. And now we see cosine is adjacent over hypotenuse. Okay, so complete this ratio for the cosine of angle A. Angle A is down here in the bottom left. Adjacent over hypotenuse, well, the adjacent to angle A is side AC, and the hypotenuse is always the longest side, that is AB. All right, the secant of an acute angle in a right triangle is the ratio of the length of the hypotenuse to the length of the side that is adjacent. So this is the reciprocal of the cosine. So now we've seen that every one of our trig functions has a reciprocal. The tangent and the cotangent is probably the easiest one to remember because you have tangent and then you have cotangent. The sine and the cosine, the secant and the cosecant don't quite match up quite as nicely. We saw that the sine and the cosecant were reciprocals of each other. And then we see the cosine and now the secant are reciprocals of each other. So now writing the secant of this angle, right, same angle A, well now we see instead of being adjacent over hypotenuse, it's hypotenuse over adjacent. Hypotenuse is still the long side, AB, and the adjacent angle A, that side that it's attached to, that is not the hypotenuse, and that is AC. Okay, getting started problems, we didn't actually do the getting started, but that's okay. We can still write these different ratios here to make sure we know what it's referring to. For each triangle, I calculated the cosine value of the angle made by the guy wire in the ground, calculate the cosine value of the other acute angle in each triangle. All right, so we're going to write the cosine of all of these different angles just to get a little practice here. So we'll start with our 53. Let me get to that page on my notes here. All right, so we have cosine of 53 degrees. So the adjacent over the hypotenuse there, the adjacent here is 300, and the hypotenuse is 500 because that's always the long side. And then if I look at my other angle, which is up here and would be 37 degrees, we also have the cosine of 37 degrees. Now the adjacent changes. The adjacent to that angle is 400, and the hypotenuse is still 500. That never changes. Okay, down here now we have the cosine of 48 degrees. Adjacent over hypotenuse here is 335 over 500. Our other angle then is 42 degrees. So we'll have the cosine of 42 degrees. Adjacent over hypotenuse now is 371 over 500. And then lastly over here, a little so I can get that better. There we go. We have the cosine of 60 degrees. Adjacent over hypotenuse here is 250 over 500. And our other angle then would be 30 degrees. And the cosine of that 30-degree angle, 433 over 500. So note what side is the hypotenuse does not change. The piece that changes is what is adjacent based on which angle we are looking at there. Okay, a guy wire is 600 feet long and forms a 55-degree angle with the ground. First, draw a diagram of this situation, then calculate the number of feet from the tower's base to where the wire is attached to the ground. Okay, so we have a guide wire here, 55-degree angle, and there's going to be the tower. Let's see. So that's my triangle there. Not a great one, but it'll work. We have a right angle here. It says the guy wire is 600 feet long. So that would be this part right here. It forms a 55-degree angle with the ground. So that's going to be my 55-degree angle right there. Calculate the number of feet from the tower's base to where the wire is attached to the ground. So we are trying to find this piece right here. So the side length of the triangle that I'm given is the hypotenuse. That's the longest side. The part that I'm trying to find in relation to this angle here, so my angle of interest is down here, is this 55-degree angle. And this x that I'm trying to find in relation to this reference angle is the adjacent side. So I want to find adjacent. I'm given hypotenuse. The trig function that uses adjacent and hypotenuse is cosine. So the cosine of 55 degrees is adjacent over hypotenuse. So in our situation, cosine 55 degrees, adjacent is x, hypotenuse is 600. To get x by itself here, we need to multiply both sides by 600. I don't know why I put a degree mark on that 600. Let's take that off real quick. There we go. So we will have 600 times the cosine of 55 degrees equals x. Once we get x by itself, now we can go to our calculator and plug this in, and we get that x equals 344.14 6. Didn't give us a specific thing to round this to the number of feet, so we could maybe go to whole feet. We'd say 344 feet on something like this. Okay, last one here, matching these up now that we have seen all of the different trig ratios, making sure we know all the different things and can match each one here. So our sine, okay, that is the opposite over the hypotenuse, so that is going to be C. The cosine is the adjacent over the hypotenuse, so that is going to be F. And the tangent is the opposite over the adjacent, so that will be D. All right, and then how I kind of like to do these with remembering which ones are the reciprocals. Well, I always remember that tangent and cotangent go together. All right, so I saw tangent was opposite over, or no, sorry, tangent was opposite over adjacent, okay? So now cotangent is the reciprocal of that, so it has to be adjacent over opposite. Okay, so that is E. And then on the other two, since they don't match up where both of them have the word, tangent and cotangent, they both have the word tangent in it. The others don't match up that way, but every one of them has to have a co. So I look at sine, well, I already labeled what cosine was, so the reciprocal of the sine has to be the other one with co, which is cosecant. If sine is opposite over hypotenuse, cosecant has to be hypotenuse over opposite, which is A. And then cosine, all right, it already has the co, so I need to go to the other one that is not, which is secant, only one left over there. Cosine is adjacent over hypotenuse, so secant has to be hypotenuse over adjacent. All right, and that is it for our trig functions.